All right, hey everyone, welcome back. And now I'm going to go over the next question. So in the function h, it's taking in an input of n, which is again an integer. And as we know, notice in the first line, there is a random generator. And do not worry too much about what it is, but basically it is just giving you a random number. Random number. All right. And then we have a for loop. In this for loop, we are going from I equals 0 until I is not less than n. So this for loop is going to run n times. N times if there is no interrupt. However, as we see inside this for loop, there is a special case that will let you to break. What does that mean? That means if somehow I'm able to reach this case, I go into this if statement, I'm going to break from the for loop and directly return from the function. And let's see. So this if statement says the next Boolean returns true with probability 0.5. So that means it is not something that is regarding with our input. It is regarding of this random generator. Therefore, since it is not regarding of the size of our input, or n in this case, we can find a worst case and a best case for this function. What is the best case? The best case is the moment you run into this function, the generator generates a Boolean number, and it is true. So you're so lucky that the very first thing you get is the one you want, and you get break from this for loop. And therefore, the best case is you're actually not running any of this for loop. And therefore, the best case is just omega 1. You're just doing this initialization, initialized I, and directly got into this if statement and break from this for loop. Therefore, it's just a constant runtime. You're not doing any loop or recursion. However, in the worst case, you are so unlucky right now. All right? Every single time you generate a random thing from this random generator will give you a false. Or every single time in this n-time loop, you're getting a false value for this if statement. And therefore, you never got break out from the for loop. And therefore, in the worst case, you need to run every single thing in this for loop, and it is a time n because you're doing this loop for n times. So in this case, we have a worst case runtime O(n) and a best case runtime omega 1. And since the best and worst case is not the same, we cannot use the tight bound, and therefore we cannot use theta in this case.